These are the frequently asked questions for Algebra 2 for Section 4.7, Day 2. Starting with number 34, we have 3x squared plus x equals negative 3. Just like when we are using the quadratic formula, we have to consider it solving, which means getting a 0. It's the same thing when you're going to evaluate the discriminant. You must have a 0 on one side. So we're going to have to go ahead and add the 3 to both sides. And then again, identify A, B, and C. But the discriminant is just b squared minus 4ac. So that will be 1 squared minus 4 times 3 times 3. That will be 1 minus 36, and that will give us negative 35. And a negative in the discriminant means we're going to get two imaginary solutions. Because remember, the discriminant is underneath that radical symbol, and when you try to take the root, the square root of a negative number, your calculator is going to tell you that's impossible. All right, then number 36, same reasoning here. We can't work with it the way it is. What we have to do is distribute that 12x, and then we have to move over that negative 3. And then we would go ahead and identify our A, B, and C, and just use the b squared minus 4ac. So we'll have 12 squared minus 4 times 12 times negative 3. And that's going to be 144 plus. And over here, we would just need to take, let's see what we have, 4 times 36. And that is 144. So we get 288. And it doesn't matter how large it is. What matters is that it is positive. So we get two real solutions. So in both of these cases, we had to go ahead and get a 0 on one side. Did a little more work in number 36 than we did in number 34. But again, you know, we just care that we're getting what we need here. These are the frequently asked questions for Algebra 2 for Section 4.7, Day 2. In number 34, we have 3x squared plus x equals negative 3. Just like when we use the quadratic formula, we have to have a 0 on one side. So it has to be in standard form when we go to solve it. So that would give us 3x squared plus x plus 3 equals 0, where a is 3, b is 1, and c is 3. And we just evaluate the b squared minus 4ac. So 1 squared minus 4 times 3 times 3. That's going to give us 1 minus 36, which is a negative 35. And again, you know, the negative 35, well, that's nice to know. Just the negative part is what tells us what's useful about the discriminant. And that is if, underneath that radical symbol, b squared minus 4ac is a negative, we're going to get two imaginary solutions. Because if you try to take the square root of a negative number on your calculator, it's going to yell at you and tell you you can't do that. So say non-real solutions. Number 36, we're going to have to distribute that 12x, and then we're going to have to go ahead and add the 3. And identify A as 12, B as 12, and C as 3. So b squared minus 4ac will be 12 squared minus 4 times 12 times 3. And that will give us 144 minus 144, which is 0. And when you get a 0 for the discriminant, that's because you have a perfect square underneath your radical. And that is to tell us that we are going to get one real solution. Just one. And that's the reason that that happens. So the graph is going to bounce off. The quadratic is going to bounce off that x-axis at one spot. Next one's 37 and 38. 37 says the weekly revenue for a company is that lovely quadratic right there, where P is the price of the company's product. Use the discriminant to find whether there's a price for which the weekly revenue would be $1,500. So where we see R, we're going to put in that 1,500. And then in order to use the discriminant, which is a part of the quadratic formula, we're going to have to go ahead and subtract 1,500 from both sides and work with it with A, B, and C. So 0 equals negative 3p squared plus 60p minus 440. So our A value is negative 3, our B value is 60, and our C value is negative 440. And we need a little b squared minus 4ac action here. So 60 squared minus 4 times negative 3 times negative 440. Well, 60 squared is 3,600. So let's see what we get here. We've got 4 times 3, which is 12, and 12 times 440. So that gives us 3,600 minus, because we have 1, 2, 3 negatives, 5,280. And it's great if you go ahead and find it, but what's more important is that it's going to be negative. So because this is negative, that would mean we get 2 imaginary solutions. Well, this was a real world problem, which means the only answers that are any good for us are real solutions. So in this case, no, it's not going to get there. We did not get one solution by getting a 0 for our discriminant, or a positive value, which would also give us 2 real solutions for that one. So this one, not going to happen. And I wrote really big doggone it, so I'll try and squish this other one over here. The equation h equals 80t minus 16t squared models the height h in feet reached in t seconds by an object propelled straight up from the ground at a speed of 80 feet per second. Use the discriminant to find whether the object will ever reach a height of 90 feet. So 90 is going to be our little h here. And we're going to move everything over. And actually, I'm going to put them in the right order while I'm doing that too, because your squared term needs to come first. And we subtract the 90. So our A value is negative 16, our B value is 80, and our C value is negative 90. And we need B squared minus 4AC. So we will get 80 squared minus 4 times negative 16 times negative 90. So again, we know 80 squared, 6,400, and 4 times 16 times 90 is 5,760. And again, we have 3 negatives here, so it's going to be subtraction. And again, it's nice to continue on and find it, but what we know is it's positive. And that tells us there will be 2 real solutions to this problem. And they just wanted to know, will it ever reach that height? And the answer is yes, since there are 2 real solutions. So discriminant, just to tell whether or not we can actually get it to that height. Then these I'll say solve it using any method you want to. When necessary, round real solutions to the nearest hundredth. And 42 has 7x squared minus x minus 12 equals 0. The first thing I would wonder is it factorable? And in this case, instead of searching, you might want to just do b squared minus 4ac. So that will give you a negative 1 squared minus 4 times 7 times negative 12. And that's going to be 1 plus, we'd have 28 times 12. And that's 1 plus 336. So 1 plus 336 is going to be 337. Now that's not a perfect square, so that tells us that this problem is not going to be factorable. So your choices at this point would be either to complete the square or use the quadratic formula. And pretty obviously in this section, they'd rather that you use the quadratic formula for these. So A equals 7, B equals negative 1, and C equals negative 12, and X equals negative B, plus or minus the square root of B squared minus 4AC all over 2A. So X equals 1 plus or minus the square root of Negative 1 squared is 1 minus 4 times 7 times negative 12 all over 2 times 7, which is 14. Now, the good part is I did the discriminant earlier, so I know that that is going to give me 337. So it was useful, even though I found out that I couldn't factor this. Let me hike this up a little bit. So x equals 1 plus or minus the square root of 337 over 14. And then you just grab your calculator and you punch them both in. You punch in 1 plus the square root of 337 divided by 14, and 1 minus the square root of 337 divided by 14. So 1 plus the square root of 337 and dividing that by 14 gives me about 1 point. Let's see, what did they say to round to? They said round to the nearest hundredth for these. So this is about 1.38. And then 1 minus the square root of 337 divided by 14, a negative 1.24. So there are the two solutions, because like I said, I mean, this is in the section with the quadratic formula. We certainly could have solved this by completing the square as well, but might as well do what the section was written for here. Then I have to go after a couple of these other problems up here with you. Number 52, which is negative 3x squared plus 147 equals 0. Well, this one, I'm not even going to try to factor this one because I can go ahead and solve. I can subtract 147 from both sides and then divide by negative 3. And then take the square root. So positive and negative 7 for number 52. Then number 54. This one I would definitely take a look at the discriminant, see whether or not this is factorable. So we have negative 4 squared minus 4 times 4 times negative 3. It was already in standard form, so I didn't have to change any of that. And negative 4 squared is 16, and then we have 4ac back there, so that's going to be 16 times 3, which is 48, so we'll be adding 48 to that, and then we have 16 plus 48, which is 64. That tells me this is factorable, so that's how I want to solve this one. Remember, we would like to factor if we can. If factoring doesn't work, then we'd like to complete the square, and then we have our fallback, which is the quadratic formula. So this is not a perfect square trinomial. I know that because of the negative 3 in the back, but that also tells me there are not a lot of combinations here. And as I look at these numbers, a negative 6 plus 2 would make perfect sense. So here, outside times outside, 2 times negative 3 is negative 6. Inside times inside, 2 times 1 is 2. And that does add to negative 4 in the middle. So that means first and first are both 2's. But last and last are plus 1 and minus 3. And then we just keep going to find our zeros. So 2x plus 1 equals 0. You'd subtract 1 and divide by 2. And 2x minus 3 equals 0. You'd add 3 and divide by 2. And there are your 2 zeros. And again, the answers are perfect. And that's one of the things in math. That's something we really love. We love having exact answers. When that happens, it makes us very happy. So let's see, on the next page we've got use a discriminant to match each function with its graph. So looking at little letter A up there, they have x squared minus 4x plus 2. I'm going to do b squared minus 4ac to see how many solutions and what kind. So that'll be negative 4 squared minus 4 times 1 times 2, and that's 16 minus 8, which is 8. That tells me this should have 2 real solutions. What that means graphically is this definitely crosses the axis the x-axis in 2 spots. So that is going to be Roman numeral 2 up there, because that's the graph that crosses in 2 spots. Then I take a look at B. And b is x squared minus 4x plus 4. Again, it's already solved. We would just put a 0 over there to use this. And then b squared minus 4ac gives us negative 4 squared minus 4 times 1 times 4. Well, that's 16 minus 16, which is 0. And that is to tell us that we are going to have one real solution. So this is a bouncer. It has to bounce off the x-axis, and that is Roman numeral 3. Process of elimination, we already know what the last one's going to be, but just to verify, b squared minus 4ac for part C up there will be negative 4 squared minus 4 times 1 times 6. So we get 16 minus 24, which is going to give us a negative 8, and that means no real solutions. These are going to be two imaginary solutions, but the no real solutions is what really tells us this is never going to reach the x-axis. That's why it does not have real solutions, and that, of course, is Roman numeral 1. So use that discriminant to tell whether or not they cross as you go through it. And that should do it.